And Narita, we can't hear you.
Thank you, Elsie. I'm sorry, everybody. So it's 3 o'clock. We can start this webinar. I'm Narita Leserri. I'm Communication Dissemination Manager in Clusters 2.0, and I would like to welcome you today to the latest episode of Clusters 2.0 series of webinars. Today we will talk about the massification concept, and I would like to welcome the speakers that I have with me today. So Marc Verelst, Elsie Sauty, Marlies de Keizer, and Marcel Huschebeck, who, by the way, is also the coordinator of Clusters 2.0. So before we begin, I would like to give you a very brief introduction on the tool that we're using today, GoToWebinar, so that you can take full advantage of all the participation tools. So first of all, please be aware that all attendees are muted by default. We can't hear you, but you're very welcome to type your question at any time in the question pane that you can find on your right. Again, because we can't hear you, we will continue with our presentations, and we will collect your questions as soon as they get in. So please use the question box at any time. Then the question manager, which in this case is Marc, will collect your questions and forward them to the right speaker. There will be a dedicated question answer time of maximum 30 minutes after the panelist discussion. Also, on the control pane on your right, you will find a tab that's called Handouts. Here, I have uploaded for your convenience some material that you could find useful. So, for example, you have the massification leaflet in case you want to have more details about this solution. And you also have the data protection statement. So please be aware that when you registered to this webinar, you accepted the GoToWebinar privacy policy. This webinar will be recorded. However, neither your voice nor face nor personal detail will be shared with other attendees. And that's the end of my presentation. I will give now the floor to Marc. Marc, whenever you're ready.
So yeah, I first want to introduce you to Cluster 2.0, which is actually a project which aims to drive a modal shift through actually implementing 3 different streams, which are in the clusters icon, which is on your right side. The first thing that is covered by Work Package 2 and Living Lab 1 is an intra-cluster collaboration tool. It actually enables clusters to operate more efficient within the cluster. And that has been developed by Interporto Bologna and has been part of another webinar. Then we have the intercluster collaboration, which we're going to discuss a part of today, in which one we have been tackling actually the use of collaborative platforms powered by Nalian on airports. And then we have another one which we are going to discuss today, which is actually an intermodal leg of the intercluster collaboration, which is covered by the Massification project. And then we have actually Work Package 4 and Living Lab 3, which is focusing on new modular loading units, actually enabling a quick shift of goods from trucks into trains, from big trucks into smaller trucks, etc. Next slide, please. Now, on Work Package 3 and Living Lab 2, which is covering the modal shift, we have actually 3 key challenges. There is no visibility on rail connections for shippers, so we don't know where actually rail connections are available. It's not like we would have the underground map like it's shown there of the London Underground, which we would like to have. There is no direct collaboration in between stakeholders, and there are a lot of stakeholders in the intermodal setup. So we have shippers, we have rail operators, we have intermodal operators, terminals, infrastructure owners, etc. How do we have them working together? And also for these companies which are supplying intermodal transportation or rail transportation, there is no visibility on transportation flows. As a result, we don't have enough volume to put on rail, and we don't have enough frequency as a result that there is not enough volume, which results in long lead times. So because you don't have enough frequency, and in high costs because you don't have enough volume, because the whole setup is dependent on the volume that you ship. Next slide, please. Within Work Package 3 Living Lab 2, we have been trying to tackle these issues through massification. And there are actually 3 legs that we're going to discuss today. First, Elsie is going to talk collaboration meetings, which have actually been developed by Euralogistic, which is the logistics clusters in Dourges, which is actually a 3-modal cluster combining road, rail, and waterway, inland waterway transportation. Then Marlies from ArgusI is going to show a tool we have developed as part of the project to show visibility on transformation flows, which is the Quickcheck Tool. And then Marcel of PTV is going to present the X-Intermodal Tool, which aims to create visibility on the rail connections. So with these 3 parts which have been developed during the project, we think we have made a nice step forward towards the enablement of a modal shift, and we're going through it now in detail with the first presentation, which will be done by Elsie. So I give the word to Elsie now, who will be presenting the Massification Workshops.
Thank you, Marc. Hello, everybody. I just take a few seconds to introduce myself. I am Elsie Sauty, European Project Manager in Euralogistic. So as Marc said, it's a logistic cluster in the north region of France. So during the next 15 minutes, I will discuss the concept of massification, the methodology of massification developed by Cluster 2.0, and the different workshops conducted in the Cluster 2.0, and finally, the advantage of the massification. So firstly, what is the massification? So the massification of flow is about bundling the flow of several companies, industrial shipper, or retailer for shipment to the same destination in order to increase the use of transport capacities. The massification concept implemented into the Cluster 2.0 project is based on using the modal shift in order to encourage companies toward a new way of shipping and a new way of perceiving its logistic organization. The massification concept is widely based on the physical internet concept, which highlights the bundling approach in order to reach an efficient, sustainable, flexible, and resilient logistic system. So nowadays, the massification is generally used in the transport plane to gather goods at one location. The massification concept implemented in the Cluster 2.0 project is more complex. Indeed, the massification into a logistic organization aims to bundle goods on the same transport mode with a capacity. It is relevant to trial the concept on the railway as the massified transport mode. Also, as we can see, the massification is more than sharing. It is optimizing transport asset, using smooth transport mode, and collaborating between the same group of stakeholders. So we can continue on the next slide, please. So through the Cluster 2.0 project and based on one experimentation in France, Euralogistic has developed a methodology for massification of flow. So first of all, I am going to present you the theory of the methodology, and then I will explain you the first pilot in France and then the workshop in Cluster 2.0. So the methodology consists of six main steps, and we will review together the different steps. So before doing this, it is important to note that in the methodology, the massification is based on a cooperation of shippers, but this methodology can be adapted to other logistic and transport actors. And as I stipulated just before, the methodology of massification is based on a first pilot in which shippers have chosen to massify their flow on a railway line. So what are the main steps? So the first step consists of a first meeting with shippers. So the first step is essential for the project. It will enable the shipper to meet each other and create a solid working group. It is recommended to have a neutral body oversee this meeting. This external organization can serve as a stable reference point throughout the project. The purpose of this meeting is to present in detail the massification process and create a trusting atmosphere. Once the shippers are convinced to get involved in the massification process, it is time to collect and analyze the shippers' data. It is the second step. Shippers will provide data on their activity to the neutral body. We advise to give this data to the neutral body to ensure the confidentiality of the data, and the analyze will determine the major common destination on which it is possible to massify flow. And to ensure that your massification project is viable, profitable, it is advisable at this stage of the process to carry out the technical and financial feasibility study, step 3. This study will analyze any physical obstacle located on the line and will determine the cost per transportation unit. It is even recommended to visit the identified terminal. We can continue on the next slide. Thanks. So the following step is to find written flow on the massified line. Indeed, massification must not be envisioned in just one direction. The identification of written flow is an essential factor in optimizing transport costs. That's why it is important to identify shippers in the country of the terminal selected, raise their awareness, and analyze their data. So once the written flow are identified, it will be time to integrate transport operators in the massification process. Step 5. Massification does not just involve shippers, it involves all the actors in the supply chain, like rail operator, for example. And the last step, but not least, is the finalization of the agreement between all actors involved in the process of massification. The signing of the agreement represents the final and essential step. It is at this time that they finalize the cost per transport unit, the volumes that will be provided by the shipper, their shipping frequencies, etc. This stage ensures that the shippers and operators remain involved for a certain period of time in the massification process. So we can continue on the next slide, please. Yes. So to develop this methodology, we based on the first pilot we were in France. So the massification project started in 2017 as a response to a demand of Procter & Gamble. P&G expected a regional logistic cluster support to identify other shippers with a similar need. Indeed, P&G aimed to increase rail freight flow from 20% to 50% shipped from its Amiens plant, the second main city in the north region of France. Nonetheless, achieving such an increment could be feasible only if our shipper will commit to load goods on the same train with P&G. So for this first project, Euralogistic has notably gathered 15 industrial and retailer shippers from the north region of France. So 7 shippers decided to be involved in the massification process. So for this pilot, we propose to shape a train because we are located on a multimodal platform, and the rail operator of this platform was ready to take the risk of the experimentation. So after studying needs and volume of the shippers, 6 destinations were identified as most relevant destinations. Shipper decided to make a massified connection from Doge inland platform to Barking in the United Kingdom. After defining the destination, it was important to define a partnership and a gain-sharing model. In order to support and strengthen the massification pilot, we commissioned some consultants to firstly work on assessment of economic components and the feasibility of the connection, and secondly, to support the group for finding logistics stakeholders in the UK to tackle the backhauling issue. So during the identification of the return flow and the visit of the Barking terminal, we realized that the Daventry terminal in the north of Barking in UK was more interesting and attractive for our massification and more particular for the return flow. So it was decided to extend the massification line to Daventry. Unfortunately, this experimentation was not successful. Several external obstacles to the massification project, like some problem with the migrants in the port of Calais and some problem linked to the Brexit, forced the operator to close the rail link between Doge and Barking. So to conclude on this pilot, we work with rail operator because we had the possibility to do so thanks to the multimodal platform in Doge. But the massification can be very well done with maritime or road transport. And massification reflects and implements the desire to reduce the carbon footprint. So thanks to this massification of flow, shippers are taking over. From now on, they will be the decision maker of the routes for the transport of their goods. So to conclude on this first pilot in France, massification is based on two principles, neutrality and cooperation. So we can move on to the next slide. Yes. So once the methodology and the first pilot was implemented and developed, it was important for us to duplicate the methodology and the massification workshop in Europe. So thanks to the living 2 of the project cluster 2.0, we aim to duplicate the methodology of massification to other TNT hubs. So we realized 4 massification workshops, one in Duisburg in Germany, one in Piraeus in Greece, another in Zaragoza in Spain, and the last one in Trelleborg in Sweden. So during this workshop, we presented the concept and methodology of massification and the 2 tools developed by the project to assist the massification process, so namely X-Intermodal Tool and Quickcheck Tool. So the 4 massification workshop was quite different. For example, in Duisburg in Germany, we helped the team of Duisburg to prepare and to plan workshop for shipper. And for another example, in Trelleborg, the workshop was in presence of rail operators, shipping lines, and ports. There was no shipper in order to respect customer rules of the port of Trelleborg. We can continue with the advantage. So it is good to talk about massification, but what are the benefits of massification? So the massification approach implemented in Cluster 2.0 comprises a wide scope of advantages that constitute a strong argument to support the relative mind shift in the logistic market. Even if the use of another transport mode generates adjustment in the logistic organization, the ambition of the experiment is to demonstrate and to argue that the massification could be a strong competitive advantage for the user. As you can see in the table, each actor of the logistic chain, like shipper, terminal, rail operator, and even society, benefits from considerable impacts by implementing a massification process. We can, for example, focus on the advantage of the shippers. So by participating in a massification project around a railway line, shipper will have access to a significant reserve of capacity. By collaborating with other companies, shipper will reduce their transport costs and have a better visibility of the intermodal network and also be more visible for the network. So we'll also be able to optimize the logistic team as much as possible. So from a larger perspective, massification has a significant impact on environmental protection. Indeed, massification induces less congestion and therefore a reduction in CO2 emission. So we can continue. Next slide, please. Yes. And now, what's going on? The Cluster 2.0 project is coming to an end, but the massification process is only beginning, so we have to keep on. It is time to understand this concept, to promote the massification, and to implement massification process as much as possible. So if you would like to have more information and to get more on massification, I advise you to have a look on the different tools we developed through the project. So the first one is a cookbook that takes up the experimentation and explains the different steps followed. So, and the second one is a game board explaining step by step the different steps of the massification methodology. So to access to this different tool, you have just to click on the pictures. And if you want to have more advice or more support in the implementation of massification process, don't hesitate to contact me in Euralogistic. So I hope this presentation was quite clear for you. And I give now the floor to Marlies de Keizer from ArgusI, who will present you the Quickcheck Tool. Marlies, the floor is yours.
Thank you, Elsie. Yeah, so I will say a bit about the Quickcheck tool that we developed in the Clusters project. I also first introduce myself. I'm Marlies de Keizer from ArgusI. I'm there, the product development lead. And ArgusI is a group of supply chain analysts, and yeah, we do projects within the supply chain to find improvements and help clients to get these improvements. If you can go to the next slide. Thank you. The Quickcheck tool, the aim of the tool is to visually show the transport synergy opportunities that are on European transport lanes. It's called Quickcheck tool because we wanted to develop a tool that is can show these results, and you have a quick view on it, so you don't have to put a lot of data or share data or things like that. Just first quick glance on what are the opportunities to collaborate for transport. I will show a short demonstration video after this slide, but I'll yeah, get first explain the tool in a nutshell. What you do is you select a transport lane that you're interested in, for example, your own biggest lane that you have in your company. And what you want to do is to compare that with other transport on that same lane and to see if there are opportunities to combine transport. And the results will show then the volumes on the transport lane, but also an indication of the cost and the savings that you could get by collaborating. And it will show the options that you have to go by truck or by train. So it will also give an indication of what it could benefit to use the train. Yeah, that's shortly what the introduction. The video we can't unfortunately play the sound, so we just get the view, and I'll try to explain it along the way.
Can I, Marlies?
Yeah, thank you. So this is the opening page for the Quickcheck tool. You will see a map on the right, which has two circles in it, a blue one and an orange one. And these are the endpoint of the transport lane that you're going to investigate. I'm not sure if it's running. Doesn't seem to do anything.
Yes, it is running.
So it probably takes a bit of time.
See, there's a small Marlies moving at the bottom.
Oh yeah, now I can see it. Yeah, so I'm now pointing to these two areas. So like I said, it's the endpoints of the transport lane that you're looking at. You can change these endpoints by putting in an address for the locations A and B. So location A is the blue one and location B is the orange one, and you can see them moving in the map if you select another location. And in that way you define your transport lane. So in this case, it's the transport between Duisburg and Bologna, and also the area that is covered by the circles. That's what the tool takes into account. So you can also increase those areas by increasing the radius of the circles. And now it will look for transport from those blue areas to the orange areas and vice versa, that we have in the database. There's a database behind the tool with all transport in Europe, and it will compare your own volumes to these European volumes. So you, on the bottom left, you will also fill in volumes that you transport between the two areas. Now it seems to stop.
It's still running though.
Yeah, but I can see that it should somehow now put in the number, and then yeah, thank you. We have to restart every once in a while, I guess. So what you do is you fill in those volumes that you have from A to B and from B to A, and then you can click the button to analyze these volumes and to compare it with the data in the database. Yeah, I'm afraid the video is not working smoothly. Can you maybe try to move it a little bit further? Maybe skip a few seconds. Yeah, I think it's running now. What it does, if you,
it is running.
Yeah, it stops every once in a while, but it's okay. So if you click on the button, you will get a new page with the output of the analysis. And on the left, you will have a list of organizations. And these are the organizations that transport products on the lane that you selected. So first of all, your own organization is in there. And then a list of the organizations that are in the database. Like I said, it's the transport in Europe that we have in it now. And we have made organizations, actually those are the product groups from the Eurostat data that we use. So each organization is actually the transport of a certain product group. You also see that some boxes are selected and some are not. The first selection is actually the best group of organizations that you can have to collaborate on this transport lane to get the biggest savings. I'll explain later what is these savings. On the right, the first thing you will get is a graph of the volumes on this transport lane. So the total weight that is transported, but also the weight from A to B and from B to A. And in the bar chart, you can see by the different colors, the different organizations, the part that they have in this total volume. And you can see it by the different colors. And also the gray one is your own volume. There's also another thing that's called lane imbalance. It's an indicator of how well balanced your directions are on this lane. So if you have somewhat the same volume from A to B and from B to A, the bigger the number of this lane imbalance, the bigger the difference between the two lanes. So you would like to have this number really low. Yeah, so that's the trucks going from A to B. It's the same number as going from B to A, and you have not a lot of empty runs. Then the next sheet you get is the cost summary. It's made up of 3 parts. The first one is the cost indicator for the transport. If everybody would just do the transport on its own, so they have everyone has their own trucks, and then you calculate the cost of that. We do not look at the absolute numbers. We just look at the differences that you could get from collaborating. So we put the basis, the individual cost on 100, and then we see what you could gain by collaborating. Collaborating, the first part means that you will combine truckloads. So for example, less than truckloads, you fill them up to full truckloads by combining transport from different organizations. And the other one is that you can use the empty trucks from one company in the opposite direction for another company, so that you fill the empty trucks. The second part of the cost saving is the savings by train. That's if you would put your transport of your goods on the train instead of using the truck. It's quite a big saving, because it's quite an optimistic way that we calculated this, because we assume that you put as much on the truck as you can. So it's actually quite a big volume that we take into account now. So that's a bit of a disclaimer at this point. That is an optimistic one. The next slide is the emission summary. It's similar to the cost, but then for the emissions. And also in this case, you can get a big saving from using the train, because it's much more sustainable than a truck, of course. Then the next one is the transport map. In this map, you see again your areas around locations A and B, and also you see some lines in between them. The green lines are actually the rail services that are optional between the two locations that you selected. We actually connect here to the X-Intermodal Tool that will be explained later on. And we show this data in the map here that you can see. Is there an option for us to go by train? And what would it look like? The orange lines are actually the options that you have by truck, so it's always an option if within Europe to use the road. Yeah, there's also some extra information. If you hover over the lines, then you can see some numbers that, for example, the CO2 emissions that you would have by rail or by truck. Then we have one more sheet, which is the background information, which just gives an overview of the volumes that are used for the analysis in this page, and also a rough explanation of the cost and emission calculation, which we developed together with Marlies de Keizer, and which is explained on this page. And that's yeah, those are all the sheets that we have in the output page. And I think it will go back to the input page now. Still some explanation on the volumes and the cost calculation. Oh, yeah, it will go back to the cost summary. For the organizations that we have on the left, it now selected 5 organizations, which is actually the best group of organizations to collaborate on this transport lane. But you can select these boxes. You can click and select and unselect them and see what happens if you would add an organization or skip an organization. And then you can see what happens with the cost and with the emissions and with the volumes. It will directly change also the charge. And somehow now it stopped again. Can you forward a little bit?
Yeah, sure.
Thank you. Yeah, so now you can see if you click a box, then immediately the charts will adjust to this new group that you selected. There's also an input box at the bottom of the list. There you can fill in, for example, if you say, okay, I wanna cooperate with one other organization, but I don't know which one. Then you can say, okay, I want to find a cluster of size 2, because you always include yourself. And then if you hit the button next to it, then you will get the best cluster of that size. You can fill in any size you want, so you can get a cluster of 2, cluster of 3, and then you can play around and see what combinations would be beneficial. There's also, you can now see that on the right, there's the bar chart, or the bar for the rail has disappeared. That's because there's not enough volume for a train to fill a train. So we have this green line in the volume chart to show what volume you would need to make the train a reasonable option. And if it's not there, then there's not enough volume to do the calculations. Can you forward it a little bit more, the video? Yeah, maybe a bit more also, because now it will explain the box. Yeah, thank you. If we go back to the input page, you can again define a transport lane. You can also move the circles and drag them through the map to define these endpoints. I now select it from around Rotterdam to around München. And then you can hit the Analyze button again and see what happens on that lane. You will get a new page. So each analysis that you do, you get a separate page that you can look around and try these different cluster options. And if you then go to the input page, you go down, you see a list of all the analysis that you've tried. And actually you can also then select in the select boxes the ones that you would like to save. So if, for example, you would want to see it later on or share it with a colleague, then you can click those boxes and download the analysis. You will get a zip file, which includes all the files that you need to view it later on your laptop, so that you have an offline version that you can view later on. So this is the demonstration video. Could you stop this one and go to the next slide?
Yeah, sure.
Thank you. So the tool, what it does is to get some first insights in the synergy opportunities that you have. So it's an accurate calculation to get the first idea of whether it's worthwhile to look further into it. Yeah, also it can compare some different collaboration scenarios. So you can select some organizations and see what happens with the costs and the savings. And the aim mostly was to keep the level of inputs low, so that it's really easy to use and really to get a first view. It's now based on Eurostat data, so the volumes that it compares your input with is with the transport in different product groups within Europe. It's actually the next step would also be to make it work with business data, and yeah, technically it can, but then it would also give some more more detailed information, less aggregate information on the collaboration opportunities for ships. This is actually my my story by the Quickcheck Tool. If you have any questions or want to know a little bit more, then you can always contact us at contact@argusi.org. And then I will give the floor to Marcel.
Yeah, thank you, Marlies. I want to introduce into the X-Intermodal tool. So as you have seen before, this is the third component. However, we also, let's say, feed it into the Quickcheck tool. So this is a kind of core component then for the, let's say, intermodal planning. And my presentation is about how collaborative intermodal planning can enable clusters to promote modal shift. So please go to the next slide. So I want to, let's say, go into a kind of story where I want to present to you on the one side the tools that we have developed, which we are calling Intermodal tool, and then also go into the application that we have done in order to assess what is the impact of collaborative planning in terms of usage of intermodal transport modes. So the X-Intermodal is a component that is composed, as you will see later, out of 3 tools. So one is we are calling the data manager. The second is what we are called the X-Intermodal route planner, and the third one is on the intermodal scheduler. So why using these kind of tools? So one is that we can compare and let's say calculate intermodal routes and show the alternatives. On the other side, it's quite important to assess on a cost level, but also on a CO2 level. So this we have integrated. Then it also facilitates the visibility for collaboration. So showing what kind of alternatives are existing on a door-to-door level. And then also we can develop and derive scenarios in order to apply analytics to show where bundling and pooling possibilities are given and compare a as-is and a to-be case. Next slide, please. So starting with the, let's say, intermodal data manager, here we are, let's say, administrating and managing the core data that are needed in order to make intermodal planning. Core data are mainly that we are administrating a transport network, that we establish or let's say include and introduce intermodal terminals and clusters. And the third thing is that we administrate and manage the actual intermodal transport services. In the next slide, I introduce you in a short video. Next slide, please. How this intermodal data manager is running. So hopefully this is running good. Okay, looks good. So firstly, it is that we administrate the network. So here, this is a screen from the intermodal data manager where we have several intermodal networks. So starting with inland navigation, we have also rail network, we have deep sea network, we have air networks, so the air links, and we have also, if you want to introduce road networks, so liner services going from one depot to the other depot. Possibly it's a little bit stuck. Yes. So what is possible here is that we open up network. So we see here, this is the rail network that is included. So it's mainly for Europe and with some links to China. And this rail network is the backbone in order to introduce and include intermodal terminals. So intermodal terminals are included as a node into this system, and that is linking then on a layer basis different kind of networks. So in this case, it's linking the rail network with the road network. Can you please, Anarita?
I'm sorry, Marcel. Yes, I. Okay.
Yes. So this is the rail network, and so this is then linking here nodes from the rail network with terminals, as you see right here. So, and once this network links is established, so we are free to, let's say, modify and link additional ones. So we can also link here, if it's a deep sea terminal, for example, we can link this terminal then to the deep sea network, like in this example, or even air freight. So if there are airports included, we can also link to this one. So we can, let's say, design and create any cluster as they are existing in real life. So what we see here, this is then the terminal management. This is how the screen. Here you see that there is the terminal name. In this case, it's Port of Ravenna. So you see it on the map. You can integrate the opening hour. So when does it open? When does it close? What kind of modes are served? And you see here also what kind of intermodal services are linked into this terminal. So we have here a screen where the intermodal services are listed. So these is a list and also, let's say, a screen from the connection that are going from one terminal to the next terminal. And let's say this terminal list creates the database, which is underlying into the intermodal data manager. And here we see how a line schedule can be administrated. So we are looking here for an intermodal rail service that is going then from Ravenna, in this case, to Bologna. So we can include here a new service that is not existing. And this goes back then to the massification approach as presented by Elsie. And here we can tick on, let's say, the days of service. When is it departing? When is it arriving? At what time frame is it operating? And then we can save it, and then it's included into the database. So this can be a kind of scenario modeling that we are doing in order to, let's say, see what the benefits are for a new service or for collaborative service that is presently not existing, however, would have impact on the let's say, the usage of shippers for intermodal transport modes. So this service is now linked to Duisburg. So given that there is now a service from Ravenna to Bologna, we can also include several stops in between, so that we are not only introducing shuttle service, but also, let's say, intermediate stops. So in this case, it's a Ravenna-Duisburg service that is going then via Bologna. And it's also actually routed on the rail network. And once it's routed on the rail network, you can calculate emissions and costs. So this will be used for the KPI assessment, showing you what kind of costs are associated to this specific lane. So thank you. I think we can stop here and go to the next slide. So in this, let's say, building up on the intermodal data manager, there is a routing engine that can create door-to-door services. And what we see here on the screen and later on in the movie, this is, we have on the left side, we have a routing request going from A to B. Then we see on the bottom line, we see, let's say, the different alternatives that have been calculated for this route from A to B. So we always get a road alternative, and then we get several intermodal alternatives. And these intermodal alternatives are assessed by different kind of KPIs. So these are cost, distances, and CO2 emissions. And based on these KPIs, you can compare your alternatives, what kind of performance might be best in order to include into your decision-making process. And in the next slide, we see a short video how this routing is actually working. So we start in Duisburg, in the area of Duisburg, where we also have then the cluster of Duisburg, starting at any point, so we can do door-to-door routing, and we go in the area of Bologna. Also here, it's not directly into Interporto Bologna, but in the area of Bologna, so that we can see how this actual door-to-door routing is taking place. So once we have created origin and destination, we set calculate route. So, and as said, there is now a performance list on the bottom showing you what kind of alternatives are actually existing. It shows the KPIs in terms of cost, distance, and CO2 emission. And once you click on the alternatives, you see then the different kind of services that have been chosen. So we have, in this case, 3 rail intermodal services going, one via the Brenner and one via the Swiss route Gotthard, using different kind of intermodal operators and services, however, going to the same destination. So you have several alternatives how you can assess this. And in this screen, you see now the possibilities that you have. So saying, for example, I don't like to go with Hupac, so I switch them off, save this, and then I make the calculation again. And so now in the second routing, you see after your selection of the preferred intermodal operator, what kind of alternative still remains. And in this case, it's an intermodal service coming from TX. And TX Logistics is using the Brenner corridor, going from Herne to Verona. And after Verona, it's taking then an end haul to Bologna. So this case might be a preferred one, so that you can use then for your decision making. Good, we can move to the next slide. So based on these core components, we have the data manager and we have the routing engine. We can apply this for a scenario building in the scheduling and optimizing tool. So we have here on the top line, we have actual transport orders. So these are coming from the cargo stream or the initial cargo stream platform of collaborative shippers, where they are publishing their transport orders. We have on the right side a visualization of the intermodal services that are existing. And then we have on the left bottom side, we have the possibility to assign the transport order on the available intermodal services. So we are using here the intermodal routing engine in order to assign concrete transport orders on these intermodal services. And what we see here in the middle, this is this green column with red bars in between. This is the use of capacity of individual services. So it is assigning actually on intermodal services transport orders, and then you see here the capacity that is actually used by this intermodal service, by these transport orders as provided by the clusters. And this planning approach we have applied, go on the next slide, please, in a scenario. So we were looking at the different clusters that we have in the clusters project and took the transport orders that we have in the database in order to plan and find out what are the optimal intermodal usage for these transport orders. So we used here, defined the capacity that is available. So we provided full train loads and let's say opened it up for let's say a potential capacity that can be transported. The next slide, please. And here this is the result and the outcome. So out of these 220,000 orders that we have for all over Europe, we first, let's say, looked at the distance. So we took only those orders that have a distance longer than 250 kilometers. And we got in total about 4,000 lanes that were relevant in order to make this assessment. So we took intermodal service data from the Clusters 2.0 location, plus some additional ones, like for example, that are not included yet, like London and Paris. And in total, we have identified that about 3,000 lanes, so 65% of all lines, only trucking is an option. However, we identified that more than 1,000 lanes, so 35%, we could identify intermodal alternatives. Next slide, please. In this assignment process, as I showed before, we identified 155 intermodal services on 37 physical lanes, of which intermodal transport orders could be used. In a total assessment, we identified that there is a potential of 60% on this cluster level over all orders that could be brought to existing services or to newly introduced massification services can be employed on this European network. So this means that we have introduced some additional massification services of highly used lanes, where so far no intermodal services is existing, introduced these into the planning tool and identified that here 60% of all cargo stream or of all streams could be used by intermodal transport. Next slide, please. So this is the introduction into the X-Intermodal tool. I'm sure we will come back to question and answer. So if you have any, please write it down into your chat.
Okay, thank you, Marcel. This was very interesting presentation by all of you. So I can see some questions are coming for the panelists. Marc, can you see them?
Yes, I can see them. I had actually 2 questions for Marcel. Whether there is a connection in between the routing algorithm and eventual booking of services. And then a question also whether there is an API to have also for Marcel to have data feeding into the system through an API to upload it in case of any questions. That are the 2 questions that I had out of the audience.
Yes. So this connection of the routing of the X-Intermodal to a booking system, this is demonstrated in the cluster community system. So this will be part of the next webinar. So we established this with the help of this intermodal operator GTS. And we will demonstrate this in the next webinar together in the context of the cluster community system. So actually this is done. And also the API, yes, there is for sure. This is a component. It's not a platform service right now, but it's a component, and there is an API how you can link to the X-Intermodal tool. So this is available, and this is existing, and this is also used.
Okay. For the rest, there are no questions from the audience. I see. The other one was, but I think there can be a connection made with Marlies. There was one input that the video was a bit blurred. That was the only. That was the other one.
Wow.
But I think that the person who mentioned it, Yassine Boula Ouazan, can connect with Marlies. We have the connection details of the people presenting at the end of the webinar, so that's possible to get into detail on the tool. Is there any other question from the attendants? Please raise it now.
So if I'm allowed to ask a question, that's actually for all of you, whoever wants to answer. What do you think? I can see that there were some problems with some unexpected problems with the massification concept due to Brexit, for example. So that was very unexpected, and now we're living another very unexpected situation with the COVID. And I can personally see here that all these tools could be useful in a time of a pandemic like ours, when less human interaction is required. What do you think?
Possibly I can start. So with the potential analysis that we have carried out, we found, I mean, this goes also back to the activities from Elsie and the massification approach. We found an enormous amount or enormous potential of freight flows going to UK. However, in one direction. So this is Europe to UK, and so there is actually no intermodal service existing that is going by rail. So mainly it's going by truck or by ferry or short sea shipping. However, there is no actual rail service existing on this corridor. Even though there are, let's say, very high numbers of volumes that are existing on this corridor. So I think that the Brexit can possibly help there. So once you have, let's say, long border lines and let's say difficulties in getting from Calais to Dover, possibly rail can be let's say help or let's say yeah, ease the burdens that will come with the Brexit. However, you still have the problem, and as we saw then also with the Quickcheck tool, that you need in both directions. You need volumes, and so far it is that the volumes coming from UK to Europe don't justify the implementation of a rail service because it has to run back. And I think this is also a kind of outcome and a kind of learning that we had then in this massification concept, where exactly this imbalance was found out and provided difficulty in the pricing and in the charging of the different partners.
Thank you, Marcel.
Okay, anything else?
Yes, Marc.
Because I guess then we are more or less done, right?
Marc, there's another question from the public I can see.
Ah, that's true. I didn't see that. There was one other one for Marcel. When the optimization is done to find the best path, is it done assuming all previous decisions are fixed? So is it actually taking into account that all decisions which have been made before are fixed ones?
Yes,
so is it each time a rerun, which what it is?
It's a gradual approach, I would say. So the first step is that the routing is providing you alternatives, and these alternatives needs to be validated by a dispatcher or by a planning expert that is assessing if this is a true and valid alternative that can be taken into account. The scheduler is actually optimizing the given transport orders with all the site conditions, so in terms of time windows, in terms of delivery restrictions, taking this into account and assign it then to intermodal services. So the outcome of this intermodal scheduler is an optimum. So this is how you best and under cost consideration can carry out your transport plan. Does this answer the question?
Yes. Yeah, because the audience said thank you, so I guess it's.
Good, very well. So do we have any other questions from the audience, or maybe some other question that the speakers want to ask to each other? Okay, so I think that we could wait a couple of minutes more, and in the meanwhile, I could give you the contacts and some follow-up info.
Okay, they are in the slides of the webinar, right?
Yes, exactly. Provided that my mouse is working. Here we go. So here you can find the contacts of the speakers in case you want to know something more about their solutions, and they will be very happy to reply to your questions and doubts, and maybe build more cooperations and explore more opportunities of collaboration. Also, please be aware that this is the third last webinar of a series. Clusters 2.0 is organizing 2 webinars more, one on the 9th of July, so the day after tomorrow, and then the final one on the 14th of July. And this will be on CLUPS and on key drivers for the European Green Deal, respectively. So let me check. I think that my yes, I know. Please let me go back. So somebody saying that that the email address of Marcel is not provided. So I will correct this before sharing this presentation with you. Indeed, this presentation deck will be made available. So you will find it on our website. There's a dedicated page for presentations. And also, you will receive a follow-up email with all this information and all the links, everything that you might need. Again, this webinar has been recorded, so you will find the full video on our YouTube channel, and here you can find the reference. And also, please follow us on our social media. So you have Twitter, LinkedIn group, and LinkedIn page. We are very welcome. You're very welcome to join. And that's the very end. Very well. So if we don't have any other question from the audience, I'd say we could close this webinar. And yes, I thank you very much for taking the time and joining us today. Also, many thanks to the speakers. It was a very interesting insights that you gave to the public. So that's all for my part. Many thanks again, and I hope to see you the day after tomorrow for next Clusters 2.0 webinar.
Okay, thank you.
Thank you.
Bye-bye.
Bye-bye.
Thank you.
Bye.